Good morning everyone. We heartily welcome back to the day 6 of AICTE Atal sponsored 6 days faculty development program on application of data science enhancing teaching and research. Scheduled from 28 July to 2nd August 2025. Organized by Department of Computer Application of B.C. Roy Academy of Professional Courses, formerly known as B.C. Roy Engineering College. Let us now felicitate our eminent speaker, Professor Dr. Snehasish Chakraborty, Professor NIT Rourkela. To do the honor, I would now like to invite Dr. Rajiv Roy, Principal of B.C. Roy Academy of Professional Courses, to felicitate our esteemed speaker with a token of our appreciation and heartfelt gratitude. Please, sir. Thank you, sir. Professor Dr. Snehasish Chakraborty has 35 years of experience as a researcher and teacher. Presently, he is a senior higher administrative grade professor in the Department of Mathematics and Academics in National Institute of Technology, Rourkela, Odisha. Prior to being, he was with CSIR Central Building Research Institute, Roorkee, India. After completing graduation from St. Columba's College, Ranchi University, he started his career at the University of Roorkee, which is now IIT Roorkee. And he did his MSc Mathematics, MPhil in Computer Application from IIT Roorkee, securing first position in the university. Dr. Chakraborty received his PhD from IIT Roorkee in 1993. Thereafter, he did his postdoctoral research at the Institute of Sound and Vibration Research (ISVR), University of Southampton, UK, and at the Faculty of Engineering and Computer Science, Concordia University, Canada. He was also visiting professor at Concordia and McGill University, Canada during 1997 to 99 and visiting professor at the University of Johannesburg, South Africa during 2011 to 2014. He has authored, co-authored, edited 18 books, published 487 research papers, 2 journals and conferences, and 2 books are in press now. He is on the editorial board of various international journals, book series and conferences. Professor Chakraborty is the chief editor of International Journal of Fuzzy Computation and Modeling, IJFCM, Indecence Publishers in Switzerland. He was the president of the section of Mathematical Science and Statistics of the Indian Science Congress 2015 to 16. He was the vice president of the Odisha Mathematical Society 2011 to 13, and he is the senior member of IEEE from 2021. Professor Chakraborty is a recipient of different prestigious awards like Career 360 Second Faculty Research Award in 2023 for the most outstanding researcher in the country in the field of mathematics, Indian National Science Academy INSA nomination in 2015 under International Collaboration Bilateral Exchange Program with the Czech Republic. Platinum Jubilee ISCA Lecture Award in 2014. CSIR Young Scientist Award in 1997. Boy Scout Fellowship in 1996. U Post Young Scientist Award in 2007 and 8. Golden Jubilee Directors Award in 2001. Roorkee University Gold Medal for the first position in MSc in 1997 and MPhil in Computer Application in 1998. He is in the list of 2% world scientists recently from 2020 to 24 in Artificial Intelligence and Image Processing category based on an independent study done by Stanford University scientists and elsewhere. IOP Publishing Top Cited Paper Award for one of the most cited articles from India, published across the entire IOP Publishing Journal portfolio within the past 3 years from 2018 to 20. He also features in the top 1% of most cited paper in material subject category. This data is from the citation record in Web Science. One of his papers has been awarded IOP Publishing Top Cited Paper Award in 2022 from India, published across entire IOP Publishing Journal portfolio within the past 3 years from 2019 to 21. And the paper was among the top 1% of most cited paper in the material subject category. He has already guided 25 PhD students and 12 are ongoing. Professor Chakraborty has undertaken around 16 research projects as principal investigator founded by international and national agency totaling about 1.5 crores. He has hosted around 8 international students with different international and national fellowship to work in his group as PDF, PhD, visiting researcher and different periods. A good number of international and national conferences, workshops and training programs have also been organized by him. His present research area including differential equation like ordinary, partial and fractional, numerical analysis, computational method, structured dynamics, FGM nano, and fluid dynamics, mathematical and uncertainty modeling, soft computing and machine intelligence like artificial neural network, fuzzy network, interval and affine computations. Today, Professor Dr. Snehasish will discuss us about fuzzy set theory and data modeling in certain environment. Please sir.
Hello? It's okay? Can you hear me? Am I audible?
Yes.
Very good morning. So, although the introduction was very long, I know you are getting bored. Hearing all these things, all are available in net. Okay? You can type my name and everything you will get there. Anyway, thank you. Thank you for mentioning in detail about the introduction. So, okay, so to start with, the titles he has already mentioned, that is fuzzy set theory and data modeling in uncertain environment. So here actually two things are there, fuzzy set theory and uncertainty modeling. How many of you know fuzzy set theory? Okay, so you know fuzzy set theory, but 90% of them they don't know, so let us discuss a little bit, okay? So as you know, this is a branch of actually artificial intelligence or soft computing. I am not going to detail what is soft computing. I know what everybody knows what is soft computing, because we have hard computing and soft computing. Fuzzy comes under soft computing. Okay. By the way, I have YouTube lecture of fuzzy set theory. You can go there. You can see I have discussed there also fuzzy or soft computing, hard computing, etc. Okay. So, as you know, in soft computing, various techniques are there. ANN, that is artificial neural network, GA, genetic algorithm, fuzzy, SVM, support vector machine, swarm optimization. There are many nowadays. Really one methods. I mean, we have hybrid methods also. Sometimes problems, sometimes ANN with fuzzy. I can combine ANN with SVM or GA fuzzy. So those are hybrid methods. When we combine two methods and get the result. So the problems that we can solve by these artificial intelligence techniques are various types. That is prediction, classification, pattern recognition, and in mathematical problems, differential equation, system of equations, eigenvalue problems. Then although those methods, those problems can be solved by other numerical or other exact methods also, but we can use artificial intelligence method also. Okay. So here one thing is there that people nowadays what I am seeing, that getting any problem they are directly going to the AI. Okay. So when a problem cannot be solved in your known methods, okay, analytical or numerical methods, then you should go to AI. Okay. Now it is a fashion, ministry is also telling AI, so everybody using AI. Anyway, so now coming to the fuzzy, those who knows, just pardon me because I have to explain what is that. So see, in crisp sense or exact sense, I have only two answers, yes or no. A question answer is correct or wrong, 1 or 0. Game of binary. I have wrong or I have correct. So when all of you are, I think, teachers. Am I correct? So teachers are evaluating the copies when some student is writing answer of the question. So if it is correct, you are giving 1. So 1 means suppose 5 marks are there, you are giving 5 marks. Now if some student could not get the answer correctly, so whether you are giving 0? No. Depends how much he or she has done it. You are not playing the game of 0 or 1. If the answer is not correct, then you are not giving 0. That means you are using fuzzy there. Means how much correct, how much degree of correctness are there. Accordingly, suppose 1 out of 5, 2 out of 5, different answers, different marks you are giving. That is actually fuzzy. You are not using 0 or 1. Okay. Similarly, a man is strong or weak. A man is strong or weak. How do you define that? I cannot define who is strong and who is weak. I can define with relative terms. Maybe somebody is stronger than me or somebody is weaker than me. Okay? So that means strong, stronger, strongest. Different words will come. Actual that set theory, crisp set theory cannot define this. It can define only if it is included in that set or not included in that set. That is 0 or 1. But in fuzzy I can play with different degrees. Okay, strong I can have different degrees from 0 to 1. 0 is the weakest, 1 is the strongest. And in between 0 to 1, 0.1, 0.2 or even 0.01 also I can play with that. How much strong is that person? Okay. Similarly, if you take correct or wrong, already I told, and then hot and cold. Okay. Suppose today hot or cold. What is the answer? Today you are feeling hot or cold? But it is not so hot. When it was May, June, that time it was hot. But you are correct, hot with some membership degree. That means I can also not define the hot. Okay, depends upon my health, environment. Okay, so those things depends. And maybe you are very prone to heat, means some person are there, they are very prone to little bit heat also. Okay, so it depends upon the person. So like that I can define hot or cold. Okay. Similarly, the place also, coldest place depends. You go to European countries, in maybe 1 degree centigrade temperature, they will walk with t-shirts. But if you will go there with all bungal cap, monkey cap or all full wear. So that means again depends upon the person, that cold or hot. So every time, everywhere we are using fuzzy. Okay. So in the class I used to tell that how many chapati you will take today in the night. They will take 2. But 2 whether thickness is given, that chapati not given. So we cannot tell how many. So there already uncertainties are there. Similarly in the problems, practical problems also, uncertainties are there. Okay, I will go into those details. So, and moreover, one thing is there that if you have the uncertainty for a problem, less number of data. Okay? Suppose we are doing an experiment, we have plenty of data, then we should not go to the first. Then we should go to the probabilistic uncertainty or any stochastic uncertainty, because we can have probability density function, we can define it, PDF, MDF, etc. Okay? We will go when we have limited number of data. Suppose I want to develop a medicine. Okay? So I have medicine to be tested. So how many rats or how many human beings will kill by testing? Okay? So there may be rats 2, 3, 4, 5. So there that is limited number of data are there. So then you should go to the survey. Suppose I want to develop a missile. So missile will be tested, real test. So how many times you will throw to the Pakistan missile? You cannot throw only in the sea you can test, but how many? That is also expensive. So there you have less number of data. Fuzzy I can apply. So like that, as I told that AI also should not be applied blindly, and also fuzzy or whatever technique you have, you should not use blindly. Okay. So this uncertainty in terms of fuzzy actually handles ambiguity. Ambiguity means when there is no certain boundary, means I cannot divide hot and cold. Okay? 20 degree may be cold for me, 20 degree centigrade may not be cold for you. Depends. So I cannot have exact margin. As the Chris theory does 0 and 1, then 0 possible. Okay? So here I can handle it. So you know his name, Professor Jade. He actually gave the notion of fuzzy selection, even fuzzy logic. Okay? So this is was actually last 5 years back, 6 years back. So he is Professor Jade, better known as Dr. Jade. So in 1965, he gave the notion of fuzzy selection. Actually, he was electrical engineer. Okay? So being electrical engineer, he did all this fuzzy sets. He published many papers, then thousands, lakhs of papers are coming now, and also it is being used in practical sense. Then in 1973, he gave the notion of fuzzy logic. So this fuzzy logic is also very important, although it is not in my today's lecture. So fuzzy logic, do you have anyone has used fuzzy logic? Right. Why you are saying that fuzzy logic is there? Nowadays all washing machine, in aeroplane, car, wherever logic is there, we have to use there fuzzy logic is there. There also you think that there is, I cannot use 0 and 1. Okay? So there I can have certain number of memberships, 0.1, 0.2 or this much. Okay? So he was the person gave this fuzzy state theory and fuzzy logic both. So I already told that whether is good or bad, maybe very good, not bad, bad. I can define these with numbers. 0.1, 0.01 depends. Similarly, Ram is tall. Again, how I define tall? Whether I am tall, then someone, he may not, he is not tall. Suppose more than the height, how do you define that tall? So I cannot define tall actually. Tall I cannot define, short I cannot define. It again relative. Maybe I am taller than you, that's why you are telling I am tall. If somebody is taller than me, then I am not tall. So you cannot define that 6 feet person is tall. So see the practicality. I cannot define in general whatever nature we have, we cannot define all those things. So that is why it is very important to have in terms of fuzziness. So these are actually, I am not going into the detail, just I am telling you, I will come back soon. This is value statement. I will come back within 1 minute. Within 1 minute, this fuzzy. And I will come back within 1 minute from certain time, 2 p.m. This is probability. So these are in general distinctions. Okay? So here, if you see the fuzziness, here boundary is value already I told. So if I write in this set theory A is equal to old, a person above 50 years is old. What about 49.8? 49 years, 8 months. What will be? Or less than that. So then we cannot divide. So what about 49 years, 11 months? Whether you tell that person is old or not. Young you tell. You cannot tell young. So there is something now you can tell old with 0.5 membership degree. That you can tell. Okay? So in fuzzy sense, set of old persons can overlap with not old persons. Here also you cannot have exact boundary. Okay? Rough boundary you can do. So now, already I told that in classical set I have the answer as 0 or 1 binary system, and those numbers we call membership degrees. Okay? So I have characteristic function there, and that maps to 0 or 1. But in fuzzy set, you have membership in the closed interval 0, 1. That means I have 0, I have 1, and between 0 and 1 I have infinite number of points, depends upon how to divide. 0.1, 0.2, 0.3 or 0.01, 0.02, like that, or 0.001. So like that you can play with your whatever problem is there, you can give the membership degree. Fine? So now if you take this example, fuzzy set actually that is why it is defined as an ordered pair. The element and its membership degree, how much it belongs. Fine? So if I consider this example, a bar is 2 or so it may be written for different numbers of x. 2 or so means what? 2 or so. What are the elements? 2.1 may come, 1.9 may come. Okay? So it will be like normal distribution. You are understanding? 2 or so. My train will be late today around 10 minutes. Although 10 minutes it goes maybe 3 hours, 4 hours. But again there are uncertainties there. Okay? Okay, so now the fuzzy set defined as like this. What I told, this is the element x, whatever, and mu u tilde, this is your membership degree of x, how it belongs. Suppose I take again, I am correcting the copies. So here may be question 1, x is question 1, and how much it is correct. Is fully correct, then it will be 1, 1. If it is not correct, it will be 1, 0. Half correct, 1, 1, 5. First question, maybe half correct. 1/3 correct, like that I can define the answers that you are correcting for the student. Okay, so I am not going into these details. Real number 0 I can define if you are interested, but it will take time. Real number near 0, again that near 0 means what? 0.1, 0.01. maybe minus 0.01. So again it will make a. So I have infinite number of points near 0. Similarly, very near 0. Now it may not go to 1. Maybe 0.001. Okay, so like that. So I can define all these things. So now suppose I define this universal set like these are the age. Okay, 5 years, 15 years, 25 years, 35 years, 85 years. Okay, so I can also define with respect to different ages this infant, young, old, senior, given different membership degree. Can I use this? So if I have, I just write a little bit 5, 15, 25, 35, 45, 55, like that up to 55. So if I write the first set infant, so these are the years actually, age. So what membership degree, if you can give this, then I will understand that you have understood what is fine. In fact, what membership degrees should be given here? As per year, as per age. Age 5 years, whether you call that infant?
Yes, one.
No.
Infant.
5 years is not infant. It is 0 levels. Membership degree is 0, not below to that. All these will be 0. Fine. Now come to young. Yes, young. What will be 5 years? Is young? Young. Young. So 1. Or maybe you cannot give 1, maybe I can give 0.7. Okay? 15? No, 0.9. Yes. 25 is young. Maybe it depends. Again, it depends upon you that you are generating. Okay? You can give no, I will give 0.8. No problem. 35? Young maybe plus 45? No. So it will be 0 point something, 0.7 or 8 or whatever. 55? Not young. So I can have from here to here. You are understanding the membership degrees that I am putting. Now come to old. 5? 0. 15? 0. 25? 0. 35? 0. 45? 0.1, 0.2, whatever is. 55? 1, because now the ladies 55 they are giving lower bar. So 1. Now what will be 1? So you understand how these membership degrees are placed as per the positions. Now come to senior. Tell me senior. From below let us go. Senior. 85 is 1. Then 75 may be 1. 55? No. So it may be 0.1 or 0.01. Even 0 also you can put. So let us put 0.01. Maybe 65? Yes.
Yes.
And these are?
0.
See, I can play for these sets, for these ages. How you write these positions. See, if I write infant for this set, okay, as I gave the example, that definition x comma mu over x. That means this infant I can write 0, 0, 0, 0, 0, 0. Sorry, 0,
I, 0,
15, 0, 25. Now if I write young, it will be 5, 0.7, 15, 0.9. So these are the element sets and corresponding membership degrees we have to write. How much it belongs to that set? Fine, for this 0, 0, 0 with comma or 5. So in this way we define a policy. I hope it will be clear. Although in one lecture it may not be, but anyway. Fine? Okay, so there are different definitions. I am not going into those things. Support of a fuzzy set. Height of a fuzzy set is height, how much it goes. Okay? Means maximum. Here height is 0. Maximum membership degree. Here height is 1. Here also height is 1. Here also height is 1. Maximum value is 1. Here maximum value is not 1. It is 0. Only 0 is there. So height is 0. Normalized for this set is if in that set you have 1. This is not normalized. These three are normalized. Okay? Alpha cut. Okay, alpha cut I can define, although I don't know whether. These are the numbers where mu a bar x greater than equal to alpha. Alpha is your these membership degrees. Corresponding to that, what are the x? Okay, I will show you by example. Even convex and non-convex set you have read, I think you know, but here fuzzy sets. There all the definitions of fuzzy set theory are with respect to membership degree. Follows the same crisp set theory, but it tells take care of the membership degrees. Okay. Similar to your crisp set, I have complement, union, intersection. Suppose I have two fuzzy sets, A and B. In general, we give bar for to distinguish fuzzy from crisp. So A bar, suppose this is x comma mu A bar x. This is the definition as per the definition of fuzzy set. X is element, mu A bar x is membership degree of A bar. Similarly, B bar. Suppose I write x mu b bar x. Fine? This is for b bar. Now if I want to find a bar union b bar in fuzzy sense. So here see for union no problem. Element wise you can do. But problem is with this membership degrees. So here mu a bar union b bar x is nothing but maximum of mu a bar and mu a bar. So this is the definition. Just take the maximum of the membership degrees for those two sets. Similarly, you have union. Union is
Intersection.
Intersection. Intersection is minimum. In place of maximum it is minimum. Then complement is 1 minus because I have only 0 to 1. So complement will be mu a bar x complement is nothing but 1 minus mu because I have up to 1. Very simple. Okay? Okay, I am not going to those things. Geometrically also I can. So here I can have those union and intersection for the bar and all. Okay? A bar and B bar. Okay, I will go after that. Okay, actually see, I hope you know the interval because see, I cannot compute any problem, practical problem using this directly membership degrees. So we have different numbers. In any problem, real number system you have till now. So real number system you have addition, subtraction, etc. etc. So in fuzzy also I need addition, subtraction, multiplication, division. So these actually all can be converted to interval system. I hope you know interval. If I write 1, 2, this is an interval. And if I write 3, 4, this is an interval. Closed interval. Okay? 1, 2, 3, 4. Left hand side limit is 1. Lowest. Highest is 2 in this set. Here 3 is the lowest, 4 is the highest. So these all I can add, subtract, etc. But it should be different than the real number system. So if I want to add this, definition is left with left and right with right. That means answer is 3, 6. Simple. For addition, no problem.
3, 6, 4, 6.
Oh, sorry. Yes, that means you are attentive. Okay. So sometimes testing. Anyway, so 4, 6, 5. So just you add left, left, right. Fine. But this, if I subtract, what will be that? Definition is 1 minus 3. Sorry, not 1 minus 3. Here it is different. It is not left, left. 1 minus 4 and 2 minus 2. This minus this minus this. So what will you get? Minus 3 minus 1. This is a little bit different than addition. So if I now subtract 1, 2 minus 1, 2, what will be that? What will be 1 minus 2 minus 1? In real number system, 2 minus 2 is 0. Same number if I divide, if I subtract, it is 0. But in interval or in fuzzy sense, it will not be 0. You see, I am not getting 0, 0. Same interval I am subtracting. 1, 2 minus 1. AB minus AB. It will not be 0 as per the definition. And that is the problem in the computation in fuzzy. Okay, so we have to be very careful. Because these things, and that is why till now you know, for crisp set, for any A, I can find A inverse if A is non-singular. I can find. But till now it is open problem if you have interval of fuzzy matrix. I cannot find the inverse. That is the open problem. Till now, Nobel Prize. Because problem is here subtraction and also division. Division also I can show you. Division in multiplication. So if I want to multiply two intervals, suppose 1, 2 into 3, 4. What will be that? See, actually, if you see 1, 2 and 3, 4, actually here I have infinite number of points, or not? Lower one is 1, upper one is 2, I have infinite number of points between 1 and 2. Similarly 3 and 4. That means actually each number will multiply with each one, or not? So 1 into 3, or 1.1 into 3.1, like that will be there. But if all are positive, no problem. You can just multiply 3 into 3 and 2 into 4. That will be answer. But if something is negative, then okay, you have to multiply almost. That time what we do? We take all the combinations of this product and then take the minimum one in the left side and maximum one in the right side. That is the problem. Okay, that way we multiply. For multiply you can do. Now come to division. Suppose I want to divide 1, 2. Two, 4 divided by 1, 2. Okay, how you do? See, one thing I forgot. Suppose what is the reciprocal? 1 by 1, 2. Suppose I have only 1 by 2.5. So if you see, it is again infinite number of divisions are there. 1 by 1, 1 by 1.1, 1 by 1.2 up to 1.2. These are positive. So I have left side 1 by 1 and 1 by 2. Which one is less?
1 by 2.
1 by 2. So it will be 0.51 for positive. If both are positive. If suppose I have minus 1 and 2. Tell me.
Minus 1.5.
See, between -1 and 2, 0 is appearing. -1 and 2, 0 is there or not?
Yes, 1 by 0.
So 1 by 0 will come.
Yes.
It will be undefined. See the problem. So division is very problematic. Here also I can do like this into 1 by 1, 2 and then I can divide. But if something, this lower wala, lower, -1, 2 or something is there, negative is there, then there is a problem. So in general, we define this division when 0 is not included in the denominator. In the denominator, due to that appearing of 0. Okay? So that is why in inverse when you find the division is there actually. 1 by, suppose you take the simple 1 by determinant of a whatever. 1 by determinant means you are dividing. So if you are dividing and appearing somewhere negative, it will be problem. Okay? So actually this, why I am telling this intervals, this is called interval uncertainty. It is called fuzzy uncertainty. This is subset actually of that. So before going to the fuzzy computation, I need to know how interval computation is done. Okay? So these interval computations, actually fuzzy set theory, I told this is subset. From fuzzy set, a fuzzy number, I can convert it to interval using that alpha cut. Okay? Then I can use this computations. Fine? So that is why this interval is very important. And again, why it is important? See, we are always teaching BTech class as Ax is equal to B, linear system of equations. We are teaching whether it is 10, 12, BTech, always we are teaching different methods. So here in this A, suppose this is a 2, I just am clearing your mind. I will show a little bit, but it's better on the board. Huh? No, so A, suppose I have A11, A12, A21, A2. Just A2 by 2 matrix or 1, 2, 3. So in Christians, I have the exact numbers 1, 2, 3, 4. No problem. We have. But if these numbers are interval or fuzzy, so in fuzzy or interval, what I will write? A tilde as maybe A11 lower, A11 upper. This is one. B11 lower, B11 upper, this is second column, A21 lower, A21 upper, A22 lower, A22 upper. So this will be interval system. Interval system of equations, and B also similarly I can have either this or this type of B1 lower, B1 upper, B2 lower, B2 upper. So this problem is not so easy to solve. And it is not that only mathematically we need. In practical application we need. Why? Where in practical application? Where in practical application we need this type of uncertainty? See, linear system of equation, if you go for the crisp one, this is having some application. I think you are teaching there. What is the application? Direct Kirchhoff's law. Kirchhoff's law. Two laws are there. There you are getting for current, resistance, etc. We get Ax equal to B form. Now, when you are measuring current or voltage or resistance, you are measuring by some equipment. If you measure or I measure, then maybe it's different. 0.001 or 0.01. That you know from physics. So that means that measurement will be in terms of some uncertainty. Maybe in terms of like this. So in actual sense, it is uncertainty, although we are using this to have some result. Okay? In this whole universe, nothing is certain. Everything is uncertain. Similarly, whole universe, nothing is linear. Everything is non-linear. Fine? So that is why these are very, very important in this one. Pardon? Okay, so after fuzzy, then we define fuzzy number. Why? Because I have real number, I I have interval number 1, 2, 3, 4 like that. So fuzzy number to be also defined. It will come from fuzzy set. So a fuzzy set will be a fuzzy number if I have three conditions satisfied. It should be convex, normalized I already defined, that means 1 should be there, that height should be 1, and this is a fuzzy set. Or also it should be piecewise continuous. So this you may not be interested, I am showing by example. Okay, I will show later. So similarly, operation of intervals I have already told you. This I am not repeating. You see? Okay, below you have, so I have already here defined. This also I will define later. Okay, this is actually, this you can see a little bit. Alpha part represented, see any fuzzy number. Actually, see fuzzy number, we have different types of fuzzy number. Okay, just try to show you from the board. So I am just now actually letting you know only the basics. Okay, some application problems are there. We will go maybe after P will go that application. Okay. So, see, fuzzy number, I have different types of fuzzy number, and it defined as fuzzy geometry. Okay, sometimes we define as triangular fuzzy number, trapezoidal fuzzy number, Gaussian fuzzy number, like that. And triangular fuzzy number we define or denote by TFN, triangular fuzzy number. Fine. We define this as three components, A, B, C. If you remove B, this is an interval. In between B will be there. If I write like this somewhere, that means I have TFN. So how you define this TFN? You see, this is your x-axis. What will be this y-axis? For distance?
Membership.
Membership. Yes. So it will be mu a bar x. If I am defining a bar as b for this set. Okay. So now this is membership degree means this bound will be only 0 to 1. Here I don't know. Depends on the problem, how far it goes. Now A, B, C, if this is A, this is C, this is B. So then B will be always 1. And this is monotonically increasing and this is monotonically decreasing. Sorry, figure. Anyway, there you can see. A, B, C. If given ABC, this is the set. TFN, triangular fuzzy number. So A monotonically increasing, see these points are going from 0 to 1 if I take this. So whatever point is there, 0.4 or 0.3 will be there for this x. If I want to write this point, so whatever number is there in the x-axis, that is your element, and whatever here, if you write, draw a parallel line, whatever cuts this is suppose 0.3, and suppose this is your point, maybe 1 or 2, 1.2. So this point is 1.2 comma 1. Okay? So similarly here the same point will come. Okay? But x is changed. X is changed. Here x is this one. But membership degree is same. For TFN. Okay? So TFN I can write in alpha part form. Means in interval form using I am not there are some mathematics is there. So if you can see the second line, this. So here it is defined as ABC. In the second line you see in terms of this ABC I am writing in terms of interval, left side and right side. Introducing a parameter alpha. Alpha belongs to 0, 1. By this if you put here, if you see, if I put alpha is equal to 0, what will be left side? A. If I put alpha equal to 0, what will get? See? So I write the interval. If I put alpha equal to 1, B. If I put alpha equal to 1, this is also B. This is also B. That means if I put alpha equal to 0, I am getting the interval. If I am putting alpha equal to 1, I am getting the middle point B. If I put different values of alpha between 0 and 1, I will get the interval x. And if I combine those, then for this it will come. So that is why I can handle this fuzzy set using interval through this alpha cut implementation. So this is your triangular fuzzy number. Okay, so again, if triangular fuzzy number, if I can convert this to through alpha cut interval, so all those that we have defined just now, that interval computation, I can do this for addition, subtraction, etc. But remember, addition of two TFN or subtraction will give TFN, but what of division may not give TFN, may not give TFN. It may be shaped different. Okay, so you can try this minus 3 to 4. Suppose minus 3 to 4. This is one TFN, minus 3 to 4, and another one is minus 106. So you can convert this using alpha cut and then do the computation that I told. All combinations depends upon left, minimum one, right, maximum. So in this way I can do the computation, and in general we do in any problem addition, subtraction, multiplication. So same with operation alpha cut. That's why I am skipping this. Okay, this also I will skip. Okay. Now come to trapezoidal polynomial. As we define TFN by 3 components, it will be defined by 4 components. So here TRFN, that is, we will write TRFN, trapezoidal polynomial. Here I will define as A, B, C, D. 4 components. Okay? And how will you define this? X, mu, 0, 1. This is your A, this is your B, this is your C, maybe this is your D. Here TFN, if I write like this, that means it is automatically, it will tell that from C to D it is 1. And this is from A to this C and C to. This is the same, trapezoid. There it was trapezoid. So this ABCD is from B to C, it is 1, sorry. This is, but nobody told me that is wrong. A, B, C, D. So B to C is 1 and A, D. A, C, if B to C is combined, then it is triangular. B equal to C. So again it is a subset actually. That triangular.
B minus C. A, B minus C or B
minus?
B minus C.
No. C. Just like here A, B, C, 3 components we define triangular fuzzy number. Here 4 components. A, B, C. I am telling from B to C membership degree is 1. Okay? And if B equal to C, it will be triangular. Triangular, no? B to C, there only one point is 1. And similarly, and this also I can write in terms of alpha cut. Again, in terms of interval. Fine?
Sir, suppose our graph will be 0, then going to 1 and it will still 1. Always.
Then it is not a fuzzy number. Convexity is not satisfied.
So it should be an interval.
Should be interval. Then it will not be. Your graph can go. Then it will not be.
0 and then it's going
Because
to
somewhere
1.
it should come, na? Closed should be, na? Otherwise, how do you define the convexity? Okay. So these are just the basic, although little bit, and also you can tell that how we handle the fuzziness in the problem. Now you see, I already told. Let us start from here. Physical systems. Any physical systems, whatever you think. I want to design a building. I want to design a bridge. I want to design a car. I want to design an aeroplane. Anything. So aeroplane design means there will be fluid. Building structure. Okay? pool, bridge, again structure, soil structure reduction will be there, or earthquake problem, tsunami problem. So there in general, any system, not always auto, I can define this by ordinary differential equation or partial differential equation. Suppose I take heat conduction problem, differential equation. You go to quantum computing, there also differential equation come. Physics you see full of. I want to study simple pendulum, differential equation. Okay, fluid dynamics, differential equation. You tell me where differential equation is not. Everywhere in practical sense where dynamics is there, differential equation. Okay? So, in general, you define a physical system by ODE or PD. But in those ODE and PD, if you see its coefficients, there are numbers sometimes. Sometimes G will come, sometimes density will come, sometimes Young's modulus will come. Okay, depends what problem you are doing. Fluid dynamics, the viscosity will come. So those parameters actually till now what you are doing taking crest part, single that. To have some result, at least to have that, solve that problem. So these parameters and variable also comes from nature in general. Young's modulus, density, viscosity, okay? Whichever you have. So these are, in general, we are taking crest, that is exact. G if I take 30 to 50%. Okay? But if you measure here, we are not taking. We are taking one because otherwise copy someone 32, 32.1, so was 100 students, 100 times the answer will come. So anyway, so that is why if it is crisp or exact, we have different methods to handle. Nowadays softwares are there, MC software, there are different softwares are there, you can solve. Whether it's structural, fluid or any aerospace or whatever. We have different types of tools software. So I can use that. Problem is, I told that these are actually measured, density or whatever. So these measure or whatever for natural nature also, these are actually non-certain. Any problem with it? All the parameters, okay, coefficients or whatever are actually uncertain. But those uncertainty may be vague, imprecise or incomplete. Sometimes we have incomplete data. Or data science says they're incomplete data. Okay? Imprecise data, vague data. I don't know whether data is correct or not. Okay? So now if this data, I already told, if you have sufficient data, large amount of data, then I can use statistics, I can use probability, stochastic. So then you should use random variable and probability density function, etc. No problem. That will be the best result. If you don't have sufficient data, no. This is just like a flow chart. Then it will come to here, 2 and 3. That is interval analysis or probability. Fine? So now if it is interval or fuzzy, I can convert this to interval using alpha cut. So now this system will convert to what? Fuzzy or interval differential equation. That means if you have uncertainty in the parameters, uncertainty in the coefficients, so you will get interval or fuzzy. So that is why in my work, in our work, we have used this interval or differential.
Sir, how we can define the uncertainty in a numerical way with the help of the fuzzy?
How we have method? I told you that x equal to b. So there you are using what method? X equal to b, suppose in crisp you are solving. What method you will use? Maybe grammar school. You have 10 class, grammar school determinant division. So in that determinant you will have all interval or fuzzy. Actually interval. So then interval computation. There determinant by determinant, d by dA or whatever, or dA by d. dA by d. So there those dA and d, you will have interval. So using those, you have to multiply now all. If you want to open 2 by 2 determinant, you have to open just multiply. Multiply using interval.
Suppose I have a parameter which has not the numerical value, that will be the value of like low, medium, high or...
No, see, if you are doing by hand, no problem. But if you are entering in the computer, You have to use some number, some digit. If you do image classification also, that image you are giving, but actually computer is taking what? Data.
My question is how we can change this type of value to numeric with the help of fuzzy. Suppose we want that how the student is good or very good or excellent or mediocre or bad, like that. So how we can
No, no,
quantify?
suppose you take 0 as the very, very bad, 1 as the very, very, very good. Okay? Now you have 0 to 1. Suppose you are telling very bad, 0.8, 8.4. Very, very bad, or sorry, bad. Some membership people.
No, that will be my conception.
It
but
will be clear.
Is there any mathematical model by which we
No, no,
can?
no, no. That you don't have. You have to, that you want, means you have to define.
Have to define
See,
by-
data when you are measuring, it is not telling that it is TFN or TRN. It is not telling. It is always any method, any theory you go, they are not telling that you follow Newton's law.
So we have to do experiments where
When you are doing experiment, uncertainty will come.
and
Any experiment you are
also
doing.
by taking these values we have to do experiments at which my
Parameter
assumptions
is
will
the
fit the model
guessable.
correctly.
Model correctly means again define how it is correct. How you say that this model is correct.
My
If you
predictions-
take, if you
predictions-
take exact value.
My-
Suppose I ask that what is the life of this building? Can you tell me what is the life of this building? When this building was made, all parameter values were answered. Brick, what is this strength? Steel inside that, reinforcements, what is this thing? You cannot say. So how you define that model? What is the answer? So that is why if you say, if structural engineer, what they do, they lead the life of a structure in the interval. Maybe 50 to 60 years it will go. Maybe. Suppose large earthquake triggers, today. So that is why practical sense of it. See, a plus b equal to c or a plus b whole square we are finding. Then you have direct formula. Okay. So suppose, okay, little bit I will tell now. Suppose this is black. Black. What is the definition of black?
No light is coming out from that. It is that.
Okay, white,
All
All
lights
the
are
colors
there.
were equal.
yellow.
Blue and green.
No, but if you are teaching to a kid, suppose I am daughter, 3 years, 4 years, 5 years, whether you tell the light is penetrating or light is not going, you teach them color on pen. This is white, this is blue, this is red, how you teach?
By showing the colors itself.
One time.
Multiple times.
You see, we don't have any, by chance it is happening. Suppose, how you say that this is an elephant? What is the definition? How you say this is a cow?
Give some parameters.
But you cannot define. You cannot define. But it will change that. So that is why no model is exact. Actually, that is what I am telling. When you are teaching a kid addition, you are telling them 1 plus 1 is 2. How you are doing? Kid, I am telling 2 years, 2.5 years, 3 years. How you are teaching?
Giving some example.
Giving chocolate.
Some.
Chocolate is better, although it will harm teeth. But anyway, chocolate we give 1, 2, again 1, 3, again you take 2 minus 1, like that. Through examples we are teaching kids. Do you have any definition for that? For addition, subtraction, you don't. From there actually this artificial intelligence has come. Means the brain of the child is being trained. What examples you are showing. What I am behaving, that training goes to the children. That is why it is being told that mere children you should behave very good. Otherwise, these are hard. Nowadays, you see the kids there. How? They have learned from home. How you train them? That is very difficult to brought up children nowadays. There are so many things to distract their mind because they learn. And from there, actually, artificial intelligence has come. You see, I cannot define addition, but they have learned addition. Maybe you give 10 digits, some kids intelligent, they will do. Without, you see, they are having multiplication, that means they are telling. Because they are trained. You ask them their capital and all, they will train. That is the training. Okay? So from there actually that neural network that I told, it has come from there. So that is, and depends upon the children's intelligence. Means suppose some children will learn by 10 examples, some will be maybe 20, 100 examples. Depends upon how his or her neurons are trained. And again, when I am becoming old, I have started forgetting things. Again, neural network. Because those connections, if you have seen the neural network, those connections loosen. Cut that. So if it is gone, then slowly. Similarly, if we suppose some problem we are doing today, after 10 years, you can ask me, I cannot tell. In chemistry, you don't know chemistry, people should not be here, I don't know. Chemistry, many equations, many formula, we have forgotten because we are not in touch of that. Our neuron forgot. But that time, when we were doing BSc, that time, so this is very practical. See, whatever we are doing in nature, we want to mimic in the computer. See, computer does nothing. Our intelligence is entered in the computer by programming or some data or whatever. So that is why model again, direct model, quadratic equation you are doing, okay, you will get some answer. But in the quadratic equation, ax square plus bx plus c equal to 0, a, b, c. It is with respect to some practical sense, na? So a, b, c may not be exact. So those uncertainty may be in different ways. This is only fuzzy. There are many uncertainty handling ways. Okay?
Nice.
Huh?
Nice, very nice.
Pardon?
Very nice, sir.
Thank you. So anyway, so that is why these are, see, we are mathematicians, I am mathematician. So whatever we have done, it is actually touch mathematics is there. And artificial intelligence is full of mathematics. Whether you do neural network, whether you do fuzzy, genetic algorithm, whether you do SVM, support vector, full nonlinear optimization is there. Home-taker condition, everything is there in mathematics. So mathematicians are the best to be success in computer science or computer application. Without otherwise, see, nowadays tools are there. When I was in Canada, so I saw in a micro oven, if you see here micro oven, when you are giving 2 minutes, about 2 minutes, 120 seconds you will give. There I saw that why I am giving 1 minute, it is taking 100 seconds. 5 minutes means 500 seconds. Why? It is wrong, na? Then I thought, no, because their brain is not like that, they can multiply 5 into 60. 5 means 500 they will enter, and inside that microwave it is programmed. That 100 means 60, 200 means 120, means like that minutes have been programmed inside that. They will not think. So that is why Indians are successful in terms of, see, all CEOs, mostly all are Indians. No, because they apply their brain and do. But they don't have time, they are using only the tools. So that is why these tools and people I have seen, even engineering backgrounds, all engineering department, they are using only tools. Suppose neural network or fuzzy or genetic, they are using, they don't know what is happening inside. Something in, some out, we tell it as what we tell it. That is the definition of ego. Garbage in, garbage out. Garbage in, garbage out. They don't know what is happening. Some problem they are solving. Fluid dynamics, we have versatile software. Structure, aerospace, versatile structure. But what is happening? Don't know. I am not telling all. But most of the students that I have seen. Anyway, I am going in different direction. So, anyway. So maybe those are better than this, no? Anyway, so that means this physical systems ODPD converted to fuzzy or interval differential equation. Now next slide is little bit different, same, but sometimes we convert to system of equation. X equal to 3, 4. So there also if the flowchart is same, if you have uncertain value is any numerical sufficient data, again it goes to fuzzy set, random variable and PDF statistics. And if you have limited data, then you do and finally converted to fuzzy or interval system of variables. So all your matrices will be in terms of linear or interval or fine. Similarly, eigenvalue problem. I hope you understand what is eigenvalue problem. X equal to lambda x. Again matrix A. There and eigenvalue problem, many applications are there. We used to teach them. All structures, all everything follow the eigenvalue problem. Schrodinger equation, all comes to eigenvalue problem. So uncertainty is there. So finally it will convert it to fuzzy or interval eigenvalue problem. So that means uncertainty is everywhere. Okay? But we are supposing that this is constant. Till now, whatever we are doing. Okay? Okay, so see, now we have uncertain systems, maybe non-probabilistic or probabilistic, I already told. Non-probabilistic means I have interval or fuzzy. In the previous flowchart I told you that if the non-probabilistic means limited number. Okay? Uncertainty is there, but limited number. Then we go to these two, interval or fuzzy. If probabilistic, then that will be. Right? So these are already discussed actually. These arithmetic operations you see. X lower, X upper already on the board I told. Y lower, Y upper, left, right. In this subtraction, this lower minus upper and upper minus lower. This is multiplication, minimum of all those combinations in the left and maximum of all those combinations in the right. And here y lower, y upper is divided, but here I forgot to write that there 0 should not be. Okay? So there is example. Okay. So should we go for tea?
Yes.
It is ready?
Yes, sir. Ready.
Ready.
Thank you, sir.
Okay.
Okay, fine. Thank you, sir.
Should I start? So here I am giving another colors why it is actually you have to be very careful. Okay. You see, I have one problem. One problem, it is like Ax equal to b, just number 2x equal to 3. X is 3 by 2. Okay. Now 2 in place of 2 I have an interval number that is 2, 3 and right side 6, 10. Right? So I can solve this by 2 methods. There are more methods. But you see, I can multiply 2 into x lower is equal to 6, left, right, and 2 into x upper, 3 into x upper is 2. So like that I can find x lower, x upper, this is 3, 10. Right? But if I do it different way, by dividing these 2, 3 right hand side, 1 by 2, 3, and as I mentioned that 1 by 3, 1 by 2, etc., what I get? 2. Different answer. That means if I handle the problem in different way, you will get different answer. So you should be careful. And then which one you will take?
So in upper case, that will be 10 by 3, 3. That will be the lower.
That is okay. That is okay. Sometimes
It will be made.
that is also a problem. That is called improper interval. It is not proper interval. You see, left side is lower, right side is.
No, in this case that will be more, but suppose that
Then it's a problem.
then we switch.
No, you cannot. You will not do it. That they are doing improper to proper. Suppose 3, 2, they are converting to 2. So those should be checked. Those are the problems that you see. Here also we are getting 2 answer, but which one I should take? One is 2 pi, another is 3, 10 by 3.
If we want to get actual results, then the upper will be very good.
Actual results.
Means near to the our
No, that
known
is not the
results.
logic, but we should take the upper one. That is fine.
Because this will be the interval is very less.
Yes. See, interval means I can give the answer minus into the plus. All answer will be there. This is not the case, na? So that means our aim is to reduce the interval. It is not that long interval will give the answer. Answer is, suppose you are finding density or something, you are finding solution. You give minus 50 to plus 50. You cannot tell that no, it is wrong. Your answer is inside that. But that is not the aim. Aim is all that and give the smallest interval. So those are there. Actually, many problems are there. That is why we are doing in Christians, all problems. But actually, in these critical problems, we need uncertainty and we need the exact. Suppose you want to begin medicine or design or planet going to aerospace or whatever. So those things to be done very carefully like this. Because last time Chandrayaan failed, na? Again they could not predict that at each step they are iteratively they are doing, if you have seen that. So slowly they are doing. So again this is with some interval they are going. So that should be again suppose large interval, so it will miss. You have to reduce the interval and iteratively we have to go. So those are the actual cases are there. So now if I solve system of linear equations with Haji parameters, I already know. So it is actually system of linear equations actually we write as Ax is equal to this is system of linear equations. As we know, A is the left hand side here coefficient matrix, B is the right hand side vector. So now if there are three cases here. If inside this A all elements are fuzzy, but inside B no fuzziness is there, crisp. One case, first case. Second case is A is crisp, B is fuzzy. Second case. Third case is A is fuzzy and B is fuzzy. This third case is more complicated. Easiest one is B is not different. Because A is crisp, if A is non-singular, then you can find A inverse into B, and B is fuzzy. So that just multiply into and you will get the result. That is the easiest case. But if A is only fuzzy, then also you have some difficulty. Okay? But both are fuzzy, then you have more difficulty. So we have handled actually all these cases. So that is why two types of, I have written here only two. Fuzzy system on the left side you see B tilde only there, tilde means fuzzy. And here all are tilde, A tilde, B tilde. Okay? So these are two types of problems. Actually three.
Why X is tilde,
X is tilde, X will be uncertain, na?
Answer will be uncertain.
If suppose this is fuzzy,
Then
so
X will
if I
be-
find X will be an interval of fuzzy sense, na? Answer will be an interval of fuzzy. That is why X tilde. Fine. So these lectures will be saved here, so you can take. PDF file is there, no problem. So these already I have defined. This triangular fuzzy number already I have defined. Okay, actually this I can write in terms of mathematical function very easily. Okay, using that 12th class straight line equation and all. Okay, so this function u over x is given by x less than equal to a lower means these are 0, and if it is greater than a right it is 0 in between these two functions. Okay, this is for TRFN already I shown. Okay, ABCD or in terms of a, just notation. These are fuzzy arithmetic operations. Same with interval, only here comes alpha. Because I can convert using alpha to interval. So all those interval computations will come here. That is why if you know the interval computation, using alpha in symbolic form, you can have addition, subtraction, multiplication. Fine? Okay, so here I am not going into the details. Actually, we have developed variety of methods. Those are available in Google Scholar. So those I cannot discuss here. So it will be just copying one method anyway. So these are just showing what are the methods and problems we have considered. Fuzzy system of linear equations using fuzzy then fuzzy complex system of linear. Complex means x plus I by 1. Okay? In CRISP also you have. Then fuzzy real system of linear equation, that also we have solved. This is not fully fuzzy we call when both are fuzzy. Both are fuzzy, A and B. So those also we have done for complex and real systems. Okay, this is one just I will skip fast. This is two methods we have developed actually for complex system of linear equations. Fuzzy. So using based on fuzzy complex center, and it's based on adding and subtracting the left and right bounds of fuzzy complex unknown and right hand side fuzzy complex. All papers are available. Okay? If anybody wants, I can say. So these four methods we have developed for fuzzy real system of equations again. We means it minus as follows. Okay? Then fully fuzzy system of linear equations also we have done. So some theorem also we have developed corresponding to that. I am not going into those, it will be boring, so I am not going anywhere. So those are there, at least those are needed. How we have developed that. So this is actually with respect to somebody has done in 1998, this Redman Atal for linear. So we have compared our method with their method about the number of operations. Because you know when I use Gaussian elimination or any other method, there are different computations are there. How many number of computations? So you see, ours is less. Okay, this present method is this one. So maybe up to here into 10 to the power 6 is there. Okay, so you see it is far less than this method. Okay, that's true. So again, fully for this system of equation, there are many things I am not going to tell you. Okay?
Sir, one thing, whatever you told that will be in the Google Scholar, that is okay. But if you want to know the details of
the paper, if you are not getting, it is not open, you write me.
Okay.
More or less it is open nowadays, but anyway. I am using alphabet, I am not going into these details, okay? I am just skipping. Many calculations, the linear programming problem also we have done, LPT. One just numerical example I will show, the method I am not showing. See 2 by 2 fully fuzzy system of linear equations. You see it is A is equal to B form. So first element is fuzzy, TFN, triangular fuzzy number 3 component, x1 tilde plus another TFN, x2 tilde is equal to right hand side element. Again second equation, same fuzzy. So this is your problem. So this using alphabet, I converted it into interval and parametric concept that alpha introducing. Finally, actually I will get, after putting this alpha form, I will get this equation 10. So using the proposed method, whatever I have told, I have not discussed, these are the solutions, okay, in terms of CA. So just one simple example. This is another example for fully fuzzy system of equations. Okay. This is some application problem with respect to where we have actually, finite element method. Everybody knows that method, I think. So we have developed fuzzy finite element. Okay. So they are actually same whatever finite element by element wise dividing of this problem. This is actually fuzzy nodal for like bridge actually. This is okay. Civil engineering problem, simplified bridge. So all dividing by element. Just I'm triggering your mind that this type of problems can be solved and fuzziness comes in there. Okay. So here nodal force is fuzzy. This P1 We have P1 and P2 we have considered as fuzzy because holes may not be crisp. With uncertainty may be TFN or TRN. So this problem have been solved. So this is static case, so it will convert to linear system of equations finally. So if you and we have taken the parameter like this. See cross section area. These are all crisp. Okay. And here if you see P1n and P2n, these are in interval in place of alpha, I have taken beta. So others are crisp. So using this and using our method, so I will show directly the solution. This is lower and upper bounds of variable displacement. Okay. This is for that is for node 3. This is for node 5. Like that. And this is interval. So some result was there again. We have compared with Friedman again Atal. So it is more or less matching. Exactly matching actually. Okay. So it seems good. This is another 6-part truss, again from civil engineering problem. Here also for the finite element have been used for this. And these are, you see, modulus of elasticity. We have taken as PFN, cross section area as PFN, all these PFN, applied force PFN, all are PFNs. So these are some example, means these two authors have solved this problem, same problem. Our method we have utilized, and these are the results. Last problem. This is that those two problems were static. As you know, static case or static analysis will convert to systematic, linear or non-linear depending on your problem. But dynamical problem, like this hydration problem, it will convert to actually eigenvalue. Okay. So writing the equation of motion using physics, okay, then Newton's law and all. So we can convert this to eigenvalue, right? So that eigenvalue problem we have solved actually, and again finite element have been used. Directly, these are some potential energy and kinetic energy. So here you see all are in terms of element, okay? You see this Mi and Ki, Mx, see Mx double dot plus Kx equal to 0. This is the differential equation that is got in dynamical problems. Mx double dot plus Kx. In general, we get like this. When force is not there, that is why right hand side is 0. Okay? So now x double dot is d2x by dt square. Right? So m d2x by dt square plus kx is equal to 0. From here, we suppose that this x is some part. This x actually is a function of x and t. Because dynamic. T will be there. That is why d2x by dt square. Okay? T is appearing. So this capital X is a function of both x and t, space and time. This we write as phi x e to the power I omega. Have you written sometime this?
Yes, sir.
What is omega there?
Frequency, natural
frequency. Natural frequency. So our aim is to find the natural frequency. So if I substitute this here, it will convert to eigenvalue problem. And that eigenvalue problem will give the natural frequency. And natural frequency is necessary to design. That you know, students are also there, although they are seeing that right most of the time I am saying. But anyway, so no, am I correct? Anyway, this is not a class. So why frequency is necessary for the students? Natural frequency is necessary. Have you heard that on the bridge, army don't march? Why?
resonance.
Resonance comes from where? Means the force frequency that they are marching and the bridge natural frequency should not match. If it matches, then it will fail. This force we know, but the bridge natural frequency, how the these will be prepared, means constructed. What type of steel, what type of strength should be there, that will make this strength. From there, I can find a natural frequency. Before that, they solve like this, and they play with this M and K. M and K is in my hand when I am designing something. M means mass, K means stiffness. In K, you have the strength of the steel or whatever material you are using. M, mass of that whole. So what mass you have to give, how much thick, how much thin, or what you. So that is in my hand. In computer I can do and see what natural frequency it is coming with respect to your host frequency. So that is why it is very important. So that is why mathematics comes after physics and engineering. Engineering problem using physics, mathematics. Then I am giving lambda, eigenvalue we are finding that they are calling frequency. Actually for mathematician it is frequency. Sorry, eigenvalue. So though, and again when I am measuring that mass or strength or something, all are answered. Fuzzy sense or any other sense. So those eigenvalue problem will be in terms of fuzzy sense, and those frequencies will come in interval or fuzzy. So according to your construct. So that is why it is very important again. So you see, this is your eigenvalue problem. U is equal to W. Their notation different, but U is equal to W e to the power I omega t. And after that I get KW is equal to lambda omega. Ax is equal to lambda Bx. We know that Ax equal to lambda is lambda x is the eigenvalue problem. Ax is equal to lambda x. In general, in the class 12 or BTech, we say this. But this is also an eigenvalue problem, lambda Bx. This is the standard eigenvalue problem, this is generalized eigenvalue problem. Sometimes, if I multiply my left by B inverse, it is non-singular. So what we will get? B inverse A. So B inverse A I can write C. So Cx equal to lambda x. So this can be converted to this. Understood? But in structural dynamics or this type of dynamical problem, we get this as the eigenvalue problem. Where this A and B or the M and K governs the system. And in that system, different parameters, weights are there. Those may be uncertain. So your eigenvalue problem will be uncertain. Means in terms of fuzzy or interval or so homogeneous beam means that beam may be homogeneous or non-homogeneous. This is material property. So we have, see here, EI. EI means Young's modulus and density. Both have been taken as PFN. Three components are there. You see? Okay. So using this, I will show the result. You see the result. Fuzzy eigenvalues of three element discretization of homogeneous beam. So you see alpha is there. So if it is 0 to 1, just for simulation, we have done 0.1, 0.2, etc. So this lower upper for first frequency, second frequency lower upper, third frequency lower upper, fourth frequency lower upper. Okay? So these are the values that we got. So this is for fifth and sixth frequency. So this is the plot for the first eigenvalue. Again a TFN. This is the first. You see, this is the second eigenvalue. This is fifth. Fixed. All the eigenvalues we have plotted. Okay. Now come to another plot. Okay. Suppose a building, generalized building. I'm taking. Actually, building 3 dimension, but just to understand, 1 dimension we have taken. Okay. So here you see different floor masses are M1, M2, Mn. Suppose any story, and those K1, K2 are the strength of the walls or whatever. So let us take just one, although it is not 1 dimension, but sometimes they solve like this also. So, and this is your, these are frequency that you have to find. Omega 1 tilde, omega 2 tilde, omega n tilde. Okay. and see with all these masses and stiffnesses are with tilde. That means those are also uncertain. So now you see this Ki and Mi for different floors. I depends upon how many floors are there. Suppose 10 floors, so I equal to 1 to 10. So here three components: lower, upper, and middle. TFM. Lower, upper, and middle. Similarly, so this is for TFM. Similarly, also TRFM also we have done. Trapezoidal fuzzy number 4 components. So all these computations we have done. So finally, we got this eigenvalue problem. Same. For the dynamics of this.
Right. In TFN or TRFN, both the results are more or less same.
No. Depends upon what you have taken.
No,
So
no,
suppose
no,
TFN you take AB, suppose 1 and 4. 1, 3, 5. You have taken. Suppose TFN. Now if I take TRFN 1, 4, 1, 3 and 5 I have taken TFN. And if I take TRFN as 1, 2, 3, 4, 2, 3, 5 is 1, 2, 3, 5. So 2, 2, 3 I have 1, 3 is 1. Then maybe this result will be inside this. Maybe. But if you change this lower and upper, okay. So again you remember here, that means from 2 to 3 you have 1. But here for only 3 it is not true. So shape may be changed. That is why I shown you that addition or subtraction of 2 TFN or TRFN will always be TRFN or TFN. But multiplication division may not be. So may not be some different shape you may get. May not be like this. Maybe this. Like this you can get. You always combine inside that. Eigenvalue problem, how many computations are there? TFN, TRFN, they will combine and give you that data. All this is our fuzzy set theory, it's not fuzzy logic. Fuzzy logic also is there. So there then rules are there, so that I am not covering. So anyway. So this is, you see the K matrix, it is a standard form actually. In structural dynamics, like this problem, it is always tridiagonal matrix. Right? So here all are tilde, and this mass matrix is always diagonal matrix. So all are with tilde, and this W is your that space variable. So finally, with respect to alpha, means because I know the interval computation, so I have converted all these to interval using alpha, and then it is this KW equal to lambda and W eigenvalue problem with respect to lambda. Okay, so these are K alpha and alpha. That's this 5-story building and come to this now. Oh, so okay. So this is with this just to have the confidence. Okay, that you are telling whether model is correct or not. Okay, so this way I can see that lambda 1, lambda 2, these are the eigenvalues or the frequencies. But here in this table, no uncertainty is there till now. Next is the with uncertainty. K1 to K5, M1 to M5, all are TFN. So how it comes? So again I am skipping, this all will be alpha in terms of alpha. So I know this is very small font. So this is a left bound, this is for left bound. And we have also computed eigenvectors also. This will also be an interval. Okay? So this is right bound. Left bound in one table it cannot be given, so 2 tables for triangular problem. So this is interval again. This is for interval material properties. Okay? Right bound and left bound. These are the plots for the eigenvalues. First frequency, triangular. Okay? Second, third, fourth, fifth. Okay? This is mode set. Although you cannot see, if you zoom that, then you can see that mode set is also means depending upon means there will be interval. Okay? These mode sets are also very important. I am not going into these details or the structural details. Okay? So this is for third and fourth mode. This is for fifth, and those are for different alpha, 0 and 1. Different simulations we have done. See that is alpha 0.6, 0.5, also in between results we have given. Okay, now these were about the application problem that I have shown related to your structure, maybe static problem or dynamic problem. Okay? So these are simple Euler, improved Euler, weighted distribution methods. Euler method and improved Euler method in numerical class we need to do. But there, if that differentiation to have that method I want to use fuzzy differential equation, then also we have developed some methods. Semi-analytical method, monotonic perturbation, those are doing that with research. Adomian decomposition, variation intersection, all those we have converted to fuzzy series. Okay? So suppose Euler method, same type of method actually, whatever the fixed strength is there, we have used that. Okay? And these are the results, solution obtained by exact method by Ma et al. Some authors have done, and we have developed. But I think audible, without it. So these are the exact value. First, second column, that is Ma et al. Given, and method 1 and method 2 ours. Okay, two types of method we have developed. So this is for other age. You know that Euler method depends upon the age, that age I am taking. So different age, small age it will be more better result. So like that. This is some another problem from bio. Fuzzy predator prey model. Again differential equation. Okay. So this is coupled differential equation first order. Here all are uncertain. You see here initial condition. Initial condition is uncertain. You see? Right now x0, x at t equal to 0, y at t equal to 0, something 15. Then it is crisp. If it is fuzzy, so I have three components, t, f, n, 14, 15, 16.
Can you check the probability value?
Okay? So again, using our method, that Euler method, we have solved this problem. This is our method. Euler method 1, method 2. Right? These are the solution for R means here alpha actually. So different age. Okay, just time now actually clearing your mind in different directions. Structure we have done. Now this is with respect to tsunami wave equation actually. Okay, again different equation. So this was actually sponsored by DRMS, that is atomic energy. So there my student worked. So linear and non-linear shallow water wave equations. Actually it is related to tsunami wave. Anyway, so this is very this age, if you see inside the sea, whether age is fixed, age is uncertain, fully uncertain or not. There we are taking age to be uncertain. Okay, and that creates actually tsunami depending upon that age actually. Okay, so interval shallow water wave equations. Yeah. So you see, I am showing only the result. Okay. So here lower and upper we can see what it is given here. Okay. So water surface elevation of linear interval SW taking h as interval, h 0.1 to 0.2 in interval sense. This is for h 0.1 to 0.2 but non-linear because there are linear differential equation, non-linear for with respect to tsunami wave. This is very important again. This is again sponsored by Department of Atomic Energy, one project. This is related to radon. Okay. Radon, have you heard? Radon gas. This is dangerous, more dangerous than this movie. And we are all in Delhi. See all these walls, floors, some gas is coming out, radon. Okay, because these are all porous. Soil also is coming out. How much? that actually measured and all. So that is very dangerous. And also this gas we have done, although it is not fully done, means we have not more work to be done, also can predict the idea of earthquake when it will come. And so one graph, although that is confidential, but anyway, confidential means it is published now, but you can, but full work it is, till now they are doing. Means in India, different places they have installed this one. Okay, this geostation. This is the geostation that we have installed in our institute. This is these are the equipments. This one is actually inside the ground. That measures the radon gas, and again it is with respect to differential equation. In experimental result we have used that coefficients and all. Okay. So here actually we have installed. You can see me. More here was there, I think. Anyway, so these are the equations, simple equation, first order. Okay, and band for behavior of radon also you have. You see the lower and upper. Okay, so these with respect to uncertainty, and just giving you the idea. So you see radon underground blasting. See, this is different. These are we have installed, but we have also tested. Suppose I told you that it can predict earthquake. So we have first tested in blasting. In the mines, when it is blasted, whether this radon is behavior is changing. Yes, it is changing. All these are ticks. So from there we have the idea. Yes, it can predict maybe, but it is not foolproof till now. Just an idea, vague idea. But we have got something that yes, during earthquake, before earthquake, actually this gives the thing. What we have seen, but may not be that for that cause. That will be actually proved. So, you see, in Myanmar, earthquake is in 2023. Yes, the day earthquake triggers here. Here the dates are there. I don't know whether you can see or not. Here some earthquake came actually in Myanmar with magnitude 6.8. Before that, maybe 2 or 3 days before, this is the radon actually concentration that we have measured. Here suddenly we got the peak. When it triggers, then we got back whether there is any peak. Yes, there was. So, but I cannot say whether it is true because maybe for different cause, some other cause it is there. So we are, they are also doing now these experiments throughout India, different places. They have installed this, and if we succeed, then at least it will be very good work. I think that if we can at least one day before also, if we know that this type of earthquake will come, it will be good. Early warning system also we can have. Okay, so just can giving ideas and. That this also in terms of uncertainty we can. Okay. Actually fuzzy more or less I have covered. Just 1 or 2 slides are there related to neural network. See, neural network people are using, but we have used internal and fuzzy neural network. Means if your data is in terms of interval uncertain, that model we have developed. In Japan, 2 scientists they have developed that, but we have developed. There are many work we have done actually. I am just showing 2 or 3 slides. Interval and fuzzy neural network. There are weights and all. I don't know if you are doing in neural network. So there we have taken all those in certain form. So this is very important again. If you see this figure, what this is? Suppose somewhere earthquake triggers. Earthquake triggers means it will release the waves, P and S waves. So waves will travel through soil, different soils. So when it triggers, it travels through soil, it comes to this building. So that wave will change. Maybe it will enhance or decrease or increase, I don't know. It will now come to this structure. So there will be soil and structure interaction. And till date, this soil structure interaction model does not exist accurately as per American Society of Civil Engineering. Okay, till date. How this waste is transferred to the structure? Because those waves are in soil. Now those waves are transferred to the structure, whether it is bridge, pool or building or anything. So that is why it is a very good example where one should use the neural network. Because you see, I have the input, earthquake can be measured, oscillograph, that acceleration I can measure, and if I place sensor, nowadays more or less critical building they have sensors. So in the sensor I can measure how it deflects. So that I can capture. Now I can play with this input and output that in the neural network is there input node and output. See, no differential equation is there as addition of two numbers, no logic. Here no differential equation, no model is there, only input data and output data. Now you play with that, train that. So after training, I can give now input, maybe suppose 6 magnitude it came, suppose 7 or 8 magnitude earthquake I can, from there I can give the strength more, with multiply. And see what will be the output of this, means how much it will deflect. So if it deflects more, this will tell them. So like that, so I can predict that by what earthquake, what magnitude, what is the distance. So those things to be done. Totally you have not done, just we have given an idea. And these when I am measuring all these sensors and all will come. Fuzzy will come. Fuzzy will come. Okay? So that is why it is shown here. If you see, building is here, earthquake source is here, seismic waves are coming, that I told, and it is transferring to this building. Then building will vibrate. And if I go to the just a figure, again, multi-story structure. So these are the floors, M1, M2, these are the masses, and K1, K2, Kn are the again eigenvalue will come. But here the ground acceleration is your earthquake. Again, this we have done with exact data. Chamoli earthquake, then Uttarkasi earthquake, we have taken data from IDUT, and then we have simulated these things. Even sensors also, passport bill in Gujarat, that also data we got, and we got very good result. That is matching. But prediction, again, we have given different strengths, earthquake and match there. It was more or less good. Okay, so this is the problem actually, where uncertainty has also been taken. So you see, these are the plots, okay, from our model and exact. Okay, dot dot one. Again, with respect to lower and upper, you see. Okay, this is done. So this is some of the books I have written. Okay, so that my all PhD students we have written. Okay, so you can go to again Google Scholar over there. Finally, this is my team. Okay, so actually I used to work in different areas: machine learning, vibration, fuzzy, maximum differential equation, stochastic and interval. So if you see the red, so these red one are working in ML, vibration blue one are working in vibration, fuzzy these green ones, and this is what? Violet. So these are related to fractional and stochastic. Okay. So with this is my contact information. If you want any clarification, letter, so you can have. Okay. So this is my Google Scholar link. You can type and you can get Google Scholar. So thank you. So if you have any doubt, any question, so you can ask. Any idea?
That's fine. But I go through your papers.
No.
No, I will contact.
So from students, no question? Right? No question?
Basically, they are not doing the farming.
No, then that's why there should be more questions. क्या होता है भाजी? भाजी की और there should be more questions. Anyway, they will take na?
No, NC.
MC. So no question, then I will stop here. I hope you have enjoyed.
Yes, sir. Yes, sir.
Only triggers your mind. See, in one day, in 1 hour, I cannot tell everything. Only I can give the idea this can happen, this can be. Okay. Anyway, thank you for
Thank
giving
you,
me the
sir.
opportunity. Huh?
Thank you, sir, for this comprehensive and insightful session. We concluded that basics of fuzzy set theory, related data modeling, and arithmetic had been discussed. In this regard, fuzzy system of equation, fuzzy eigenvalue problems, and fuzzy differential equations will be introduced in brief. Further, few challenging interdisciplinary problems had been discussed in fuzzy uncertain scenarios. The target of this session is to meet the present and future need for the interaction between various science and technology or engineering areas on the one hand and corresponding data handling in such uncertain forms with different types of fuzziness utilizing novel and newly developed computation on the other. Thank you, sir. Thank you very much. Now I call our co-coordinator, sir, to proceed this session. Sir.
Okay. Thank you.
নর্মাল ফটো
হয়ে গেছে স্যার স্যার হয়ে যাবে
আরেকটা তুলে নেন।
ভালো করে